Hello students, welcome back to our chemistry online classes. So in our solid state, today's our topic is close packed structures. So in solids, the constituent particles are close packed, leaving the minimum vacant space. So let us consider the constituent particles as identical hard spheres and build up the three-dimensional structures in 3 steps. So what are they we are discussing now? So here the first one is close packing in one dimension. So in one dimension close packing, there is just one way of arranging the sphere, that is a straight line. So here each atom or ion or molecule is get attached with other two atoms. So here the coordination number will be 2. So what do you mean by coordination number? Coordination number of an atom or an ion in a solid crystal is the number of nearest neighboring atoms. So for this, the nearest neighboring atoms are these 2. For this 2, isn't it? So that's why the coordination number is 2. So this is close packing in one dimension. Next comes to close packing in 2 dimensions. So in close packing in 2 dimensions, it can be arranged in 2 ways. So what the first way? Square close packing, hexagonal close packing. In square close packing, the atoms are arranged like this. The spheres are arranged in one above the other. This can be done in 2 ways here, that is hexagonal and square packing. So spheres are arranged in a row and the sphere of the second row are placed exactly above the first row, isn't it? The first sphere are arranged in a row and the sphere of the second row are placed exactly above the first row. So here each sphere is arranged horizontally and vertically such that each sphere is in contact with 4 other spheres. If we see here, see this sphere is in contact with 4 other spheres. 1, 2, 3, 4. If we take this one also 1, 2, 3, 4. Isn't it? So here what will be the coordination number, children? Here the coordination number is 4. So if we call the first row as A type, the second row also exactly same as the first row. So it is also called A type. So this type of arrangement is called A type of arrangement or square close packing. I hope you understand. So here the arrangement is same, that is why it is called A type of arrangement or square close packing. Next move to the hexagonal close packing. In this type of packing of sphere, the second row of the sphere is placed in a staggered manner such that the sphere is fitting in depression. Fits in the depressions of the first row, isn't it? Depressions of the first row. If we call the first row as A type, then second row is different from the first row, isn't it? So it is called as B type. Now if we place the third row above the second row in a similar manner, we will observe the third line sphere is same as the first line. So again we will name it as A type. And again this one will be B type. So here each atom contact with other 6 spheres. See, 1, 2, 3, 4, 5, 6. Yes. So when this is contact with other 6 spheres, the coordination number is 6. So this type of arrangement is called AB type of arrangement or hexagonal close packing. Hexagonal close packing. If we compare the square close packing and hexagonal close packing, more empty space will be present. Here more empty space will be present. Here less empty space will be present. So now what are these empty spaces and what do they play in a packing efficiency? What role do they play in packing efficiency? These empty spaces. So these empty spaces are called as voids. Okay, VOIDS, voids. These are responsible for decrease in packing efficiency of the solid crystal. More the number of voids, less the packing efficiency of the crystal. Now C type is close packing in 3 dimension. Close packing in 3 dimensions. So 3 dimension close packing from 2 dimensional square close pack layers. It can be obtained by placed 2 dimension square close pack layers above the first one such that the spheres of the second row are exactly above the first layer. In this type of arrangement, both the layers are perfectly lined horizontally and vertically. They are perfectly lined. So on arranging the layer one on the other, you will get the structure like this. Okay. sorry, structure like this. So if we see the structure in, see here the coordination number, what will be the coordination number? Here the coordination number is 6. Here the coordination number will be 6. See how? 1, 2, 3, 4, 5, 6. Okay, if you join like this, the 6 can be separated. Okay, 1, 2, 3, 4, 5, 6. This is center atom. Now if we see 1, 2, 3, 4, 5, 6. So 6 is the coordination number to this central atom. The 6 other atoms are get attached, and all these are arranged exactly in the same manner. That is why this type of arrangement is called A type of arrangement. If we observe carefully, this arrangement has generated a simple cubic lattice, and its unit cell is primitive cubic unit cell. So like this. So it's looking just like this, isn't it? Yes. And the next one is now close packing in hexagonal close packing by placing two-dimensional layers one over the other. In that, placing the second layer over the first layer. If we place the second layer over the first layer like this, okay. If we place a layer of a sphere in their depressions, we find triangle voids for the first layer. For the first layer, okay, look at here. This is the first layer, this is second layer. So if we see here a triangle void, so voids are nothing but empty space. A triangle void is formed, isn't it? So it is not clear. All the triangle voids of the first layer were not covered by the second layer. This gives rise to different arrangements and different voids. So what are the different arrangement and different voids? So voids are of again two types. Voids are of again two types. Tetrahedral void, octahedral void. Tetrahedral void and octahedral void. If we see here, okay, at some places the first row we will get tetrahedral void, and for the second row we see octahedral void. Understood, children? For the first row, see tetrahedral void. Here a triangle void is formed, isn't it? In the here, this one is called tetrahedral void, and here it is formed octahedral void. Octahedral void means how many atoms are there? 1, 2, 3, 4, 5, 6. Okay, octahedral void is formed. So since the tetrahedral void is formed by joining the center of the four surrounding spheres, while at the other places we will notice that the triangle voids of the first layer coexist with the triangle voids of the second layer, such that there the triangle shapes do not overlap in such places, and then another type of void is formed, that is nothing but octahedral void is formed. Since it is formed by joining 6 surrounding atoms or 6 surrounding spheres, in case we need, if you want to calculate the number of tetrahedral voids or octahedral voids in a crystal structure, then we should know the number of spheres will serve the purpose. Okay, we should know the number of spheres. Suppose there are n spheres in a crystal structure, then the number of octahedral voids, or means octahedral voids generated, will be n. Then the number of tetrahedral voids generated will be 2n. And next, coming to placing third layer over the second layer. It is of two types. It can be done in two ways. First one, covering tetrahedral void, and next one is covering octahedral void. First one is covering tetrahedral void. Tetrahedral voids of the second layer can be covered by placing these pairs by third layer on them. See, look at here, 3 layers. Okay, A, B, and again this type will be come down. Okay, so this pattern is called AB pattern. Okay, in hexagonal close packed or HCP, hexagonal close packing, or shortcut HCP. In this type of spheres, each sphere is contact with other 12 spheres. Look at here, 1, 2, 3, 4, 5, 6, 1, 2, 3, 1, 2, 3. So 6 from the middle layer, 3 from the bottom layer, and 3 from the upper layer. So here each sphere is contact with other 12 spheres. So here the coordination number will be 6. Sorry, coordination number will be 12. Example, you can take zinc and magnesium. Understood, children? So in this type of spheres, each sphere is in contact with 12 other spheres. 12 other spheres. This is central atom which is contact with 6 here, 3 here, 3 here. Total 12 other spheres. So here the coordination number will be 12. So next one is by covering octahedral void. In octahedral void, the second layer is covered by placing the third layer over them. On doing so, the spheres of the third layers are not aligned with the spheres of either the first layer or the second layer. So they are not same. So what type of pattern we will get? A, B, C. Here again A, B, C. Like that the pattern will be going on. So here also same. Here A, B, C. So here 6, 3, 3 is in total 12. So here also same, the coordination number is 12. So this is called cubic close packing or CCP. The structure will be CCP, cubic close packing or face-centered cubic form. Understood, children? So this is about the close packed structures. In the next class we are going to see the class about locating tetrahedral void and octahedral void. I hope you understand today's class. Thank you, children.